Hello, am I audible? Hello, students, am I audible? Hello. Good morning, dear students. So, yesterday's class, we were discussing about some of the basic concepts of chemistry. So, we have deal with atomic mass, right? So, we have seen the definition of atomic mass unit, AMU, right?
For 1 minute.
Then
So,
yes.
Can you start at 10:05, ma'am? People are entering.
Okay, sir. Okay.
10:05, ma'am. Thank you, ma'am.
Okay.
You can start now, ma'am.
Yes, sir. So,
RICHA,
good morning.
you can start.
Yes, sir. Yes, sir.
Thank you.
Good morning, everyone. So, yesterday's class, we had discussed about some of the basic concepts of chemistry. Okay, so which all definitions we have seen? So atomic mass unit, okay, then average atomic mass. So we had solved some examples on them. Then we had seen different scales of temperature. So we had solved example on that. Then equivalent mass, right? Equivalent mass definition, formula, and their examples. Then we had started with mole concept, right? So what is mole? Mole is nothing but the amount which has same number of entities as there are atoms in exactly 12 grams of C12 isotope. What is the value of mole? It is 6.023 into 10 raised to 23. Okay. So this is nothing but it is called as Avogadro's number. Okay. It is called as Avogadro's number. And okay, it is called as Avogadro's number and it is denoted by Na, capital N and subscript A. So this is said to be a mole. Okay. So we had discussed about the formula. So how the mole is given if when we are calculating the amount of substance. Okay. So when the amount of substance is given, how to calculate the number of moles? So it is the amount of substance in gram upon the atomic or molecular weight in the gram. So based on this, we had solved yesterday two problems. So these were the two problems. So so here we had to calculate how many maximum numbers of atoms are present. So in A option, you can see what is the definition that the atom which has exactly 12 grams of C12 isotope. Okay. So here in A, 24 grams of carbon C12, right? So it has 2 moles and rest all 56 grams of Fe, then C option 27 grams of Al, D option 108 grams of Ag. So you can see in the other three options that it is only 1 mole, while in A option you can see it is 2 moles. So A option is the right one. It is the maximum number of mole which is present is in 24 grams of carbon. Okay. So then we had discussed about the, so this was the another question we had solved. So next we'll see this particular problem. So what is the question? Which one of the following has maximum number of atoms of oxygen? So there are four options. Okay, you can see A option 2 grams of carbon dioxide, B option 2 grams of carbon monoxide, C option 2 grams of water, D option 2 grams of sulfur dioxide. So you have to calculate in which among this has a maximum number of oxygen atoms. Okay. So how to calculate? So how to calculate the first one? Okay. So 2 grams of carbon dioxide. What is the molecular formula of carbon dioxide? It is written as, just a second. Yes. So it is CO2, right? So how to calculate it? So you have to relate. So carbon dioxide, what is the molecular mass of this? So carbon is 12. Each oxygen is 16, right? So 16 plus 16, 32 plus carbon. So it becomes 44. So 44 grams of carbon dioxide is nothing but your 1 mole. Okay, it is 1 mole. So we have to see, so in this particular 44 grams of carbon dioxide, how many moles of oxygen? So there are 2 oxygen. So it is said to be, it is 2 moles. Okay, it is 2 moles of oxygen are of oxygen atoms. Okay, so we have to calculate for how many? We have to calculate for 2 grams of carbon dioxide. Okay, so for 44 grams of carbon dioxide, which is equals to 1 mole, it is having 2 moles of oxygen atoms. So for 2 grams of carbon dioxide, how much? So you have to cross multiply and it will be 2 upon 44 into 2. Okay. So what will be the answer? Try to solve this. Yes, try to solve this. What will be the answer? So you have to find out how many maximum number of atoms are present, okay, of oxygen. So in each case, you can see carbon dioxide, carbon monoxide, water, sulfur dioxide. There are oxygen atom present. So what you have to do, you have to relate. So carbon dioxide, what is the molecular formula? It is CO2. So how many, what is the molecular weight? It is 44 grams. So 44 grams of carbon dioxide gives you how much? It is 1 mole. So right, it is 1 mole. It is said to be a mole. So that much carbon dioxide. So how many oxygen atoms are there in carbon dioxide? It is 2. 2 atoms. So it is said to be 2 moles of oxygen atoms. So for 2 grams of carbon dioxide, how much moles of oxygen atom is present? So you have to cross multiply. You have to relate this and cross multiply. It will be 2 into 44 divided by 44 into 2. Okay, it comes to 1 by 11. So after solving this, how much you are getting? Try to answer. It will be 0.091. Okay, this much mole of oxygen atom. So this is with respect to A option. So we have to like this calculate for all other options and we have to see which has the maximum. Now in second case, that is 2 grams of carbon monoxide. Carbon monoxide is what? CO, right? Carbon is 12, oxygen is the atomic mass is what? It is 12 and this is 16. So it comes to what? It is 28. Okay. So it is 28. So 28 grams of carbon monoxide is related what? It is 1 mole, right? So in this, how much oxygen atom is there? 1 oxygen atom. So it is said to be 1 mole of oxygen atoms are present in carbon monoxide. So in 2 grams of carbon monoxide, how many moles of oxygen atoms are present? So you have to cross multiply and what you will get? You will get, so 1 divided by, okay, 1 into 2 divided by 28, right? So what will be the answer? Try answering. What will be the answer? 1 by 14. It comes to be 0.071 mole, okay, of oxygen atoms. So this is for B option. Similarly, we have to solve for C. So 2 grams of water. Water is what? H2O. H2O. So hydrogen, what is the atomic weight? It is 1. So 2, right? 2 plus oxygen is 16. So it is 18. So 18 grams of water is what? It is 1 mole. So how many oxygen atoms are present? Only 1. So it is said to be having 1 mole of oxygen atoms. Okay. So for 2 grams, how many 2 grams of water, how many moles of oxygen atoms are present? So how you, what will be the, you just cross multiply, what it will be? So 1 into 2 divided by 18. Okay, 2 ones are, so after simplifying, what is the answer coming? It is coming to be 0.11 mole of oxygen atom. Okay, so this is with respect to the C option. Now we'll solve for the D, that is sulfur dioxide. What is the molecular formula for sulfur dioxide? It is SO2. Okay, so sulfur, what is atomic weight? It is 35. So it comes to be plus 16 into 2. Okay, it comes to be 64. It comes to be 64. Just a second, I'll clear this. We'll have limited space. Okay, so it is 64. So 64 grams of SO2. Okay, it is said to be 1 mole 1 mole, it has how many oxygen atoms? It is having how many oxygen atoms? There are 2 oxygen atoms, right? So 2 oxygen atoms. So it is 2 moles of oxygen atoms. 2 moles of oxygen atoms. So in 2 grams, how many you have? So you have to cross multiply. So it will be 2 into 2 divided by 64. Okay. So this comes to be 0.62 mole of oxygen atoms. So just see. So in from carbon dioxide, how much moles you are getting? It is 0.091. Okay. Then B option 0.07. C, how much you are getting? 0.11. And D, it is 0.62. So among this, which is having maximum number of atoms of oxygen, it is D. Okay. So 2 grams of sulfur dioxide. So this is the right answer. So like this, you are going to find out the maximum number of atoms of oxygen. So you have to relate it with the original, and you have to write simultaneously. Okay. So next question, we'll go to the next question. So mass of 0.1 mole of methane is, okay, what is methane? Methane is what is methane? CH4, right? Methane is CH4, right? So calculate the molecular mass. So carbon is 16 and each hydrogen is 4. So it will be how much? Carbon is 12 and each hydrogen is 1. So it will be how much? 16, right? 16 grams. So how we will relate here? So 1 mole of CH4. Okay, methane is consists of how many? It is 16 grams. Okay, it has 16 grams, 1 mole of methane. So for 0.1 mole of methane, okay, how much? Okay, you have to cross multiply. So you have to relate this with the definition. So 1 mole of methane, it consists of 16 grams, right? So for 0.1 mole of methane, it is how much? So cross multiply, it will be how much? So just see, 16 into 0.1. Okay, it comes to 1.6. So this is the answer. So the answer is A. So like this, you are going to solve the problem. Okay, you have to relate and you have to write the problem. So we'll go for the next one. So this is when amount of substance is given. Okay, this is with respect to amount of substance. Next, we'll see with respect to when entities are given. Okay, so formula to find number of moles when entities like atoms, molecules, or particles are given. So when number of moles can be found when number of particles at HTP divided by Avogadro's number. What is Avogadro's number? It is 6.023 into 10 raised to 23 atoms, right? So whenever you're finding the number of moles when particles are given or the entities are given, so it will be at HTP, that is standard temperature and pressure, divided by Avogadro's number. Okay, so we'll see a problem based on when entities are given. So how many moles of electrons weigh 1 kilogram? So what is the mass of the electron? Mass of the electron is given as 9.108 into 10 raised to minus 31 kg. Okay. And Avogadro's number, you know Avogadro's number, it is 6.022 into 10 raised to 23. Okay. So now how we will relate it? So what is the mass of one electron, right? So we'll see the solution, how to solve this problem. So solution, first is what you have to relate. So 9.108 into 10 raised to minus 34. 31. Okay, 31 kg. It is what? It is the mass of what? It is a mass of one electron, right? STP full form is standard temperature pressure. Okay, at standard temperature and pressure. So 9.108 into 10 raised to minus 31 kg is the mass of one electron. So what is the mass of 1 kg? Right, mass of 1 kg is what? Okay, so it is what? So it is 1, how we will relate it? So it is 1 divided by 9.108, 1 kg, right? So it is how much? So 1 divided by 1.08 into 10 raised to minus 31, right? So how many moles of electrons weigh 1 kilogram when mass of the electron is 9.108 into 10 raised to minus 31 kg and Avogadro's number is given. So whenever the number of entity is given, what you have to do? You have to take the number of particles at standard temperature pressure and divided by Avogadro's number. So what is a first step? We have to, what is given is one mass of one electron. So what is the mass of one electron? It is 9.108 into 10 raised to minus 31 kilogram. Okay, so what is the mass of 1 kg? Okay, you can, for much simplifier, you can just write here. So what is the mass of 1 kg? Question mark, right? So cross multiply, how it will come? You have to solve it as, so 1, so cross multiply, it will be 1 divided by 9.108 into 10 raised to minus 31 kg. So this is with respect to 1 kilogram. So simplifying further, 1 you can take this upside, so it becomes 9.108. So when 10 raised to minus 31 goes up, so it becomes 10 raised to 31. Okay, the negative change into positive. So many electrons are present in 1 kg. Okay, so many electrons are present in 1 kg. So further, what you have to do, what is the, so this is the mass of 1 kg electrons. So further, what you have to do, you have to divide it by Avogadro's number. So 10 raised to 31 divided by 9.108 into what is Avogadro's number? 6.022 into 10 raised to 23. So these many mole of electrons are present. Okay, so you have to further simplify. You can see you have to further simplify. What you can do, this 10 raised to 23, you can take it upside. So it will be 10 raised to 31 minus 23 divided by 9.108 into 6.022. So what is further simplification? What it gives you 10 raised to 8 divided by 9.108 into 6.022, right? So which is our correct answer? It is this D. Okay, so this is the correct answer. So what is given? You have to find out the number of moles in 1 kilogram. So you know what is the mass of electron, you know Avogadro's number. So you have to relate it. So what is mass of one electron is this much. Mass of 1 kg of electrons, you don't know. So just cross multiply, you will get the number of electrons in present in 1 kilogram. Then what you have to do? You have to divide it by the Avogadro's number. So these many electrons are present, or these many moles of electrons are present in 1 kilogram. Okay, so this is the correct answer. So this is the way you have to solve this particular question. So we'll go for the next one. So another type. So when formula to find number of moles when volume of a gas is given at standard temperature pressure, that is STP. Okay, so whenever number of moles are to be found out of gas, okay, when gas molecules are given, so it should be how you can calculate number of gas at STP upon standard molar volume. What is standard molar value volume? What is its value? It is 22.4 liters. Okay, this is the standard volume, it is 22.4 liters. So whenever the number of moles are to be found out of volume of gas, okay, whenever a gas is given at HTP conditions, so this is the particular formula you are going to use. So we'll see further. So this is a particular example based on volume of a gas, okay, whenever a gas is given. So now it is a methane gas. So you can see it is a methane gas. So the mass of 112, okay, 112 cm cube, that is centimeter cube of methane gas as at STP is, okay. So how do you solve this? So what is the standard, this STP standard molar volume? It is 22.4, or it can be written as 22,400. Okay, 22,400 centimeter cube. Okay, so that was in liters. So when you convert it into centimeter cube, it will be 22,400. So 22,400 of methane, okay, at STP has how much grams? What is the mass? It is 16 grams, right? 12 plus 4. 12 carbon is 12, hydrogen is, each hydrogen is 1. So it is into 4. So it will be 16 grams. So 22,400 cm cube of methane at STP has mass. It has the mass of 16 grams. Then we have to find it for what? 112. So 112 cm cube of methane at STP has mass how much? Okay, you have to cross multiply. So what is the relation? So 22,400 cm cube of methane at STP has mass. How much mass it has? It is 16 grams. So you have to find out for how much this. It is for 112 centimeter cube of methane at STP as how much? So just cross multiply. How much you'll get? So 16 divided by 16 into 112 divided by 22,400. Just solve this. Solve this and tell me the answer. Try solving this. Just simplify. Yes. Simplify. How much it comes? Four, 6. Easy simplification. Just see. Yes, correct. So it comes to around, so 2. So you will get, so it will be 0.08. Okay, so correct. So this is the correct answer, C. Okay, C is the correct answer. So understood this. So you have to just relate it with the standard definition. Okay, so this is how you have to solve when volume, when you have to find the moles, number of moles when volume of a gas is given. So we'll go further. Next. So for the reaction, okay, the next question is for the reaction. Just a second. For the reaction Fe2O3 plus 3CO, okay, gives you 2Fe plus 3CO2. The volume of carbon monoxide required to reduce 1 mole of ferric oxide is. So what is the question? So your ferric oxide is been reduced. Okay. So how much amount you have to find out how much amount of carbon monoxide is required to reduce. Okay. What is reduction? So here it is reduction. Okay. So your Fe2O3, it has been reduced. So how much amount of carbon monoxide is required to reduce ferric? Okay, to reduce ferric. So reduction is what? What is reduction in terms of electrons? What is reduction in terms of electrons? Yes, anybody? What is in terms of electrons? Gain of electrons, right? Gain of electrons is reduction. And what is oxidation? Loss of electrons. So we have to calculate the volume of carbon monoxide required to reduce 1 mole of ferric oxide. So write the Fe2O3 plus 3CO gives you 2Fe plus 3 carbon dioxide. So what it is asked, how much volume of carbon monoxide required? So how many moles are used here? Just see how many moles are used. It is 3 moles, right? It is 3 moles are used. So 3 mole you have to, so how to calculate 3 moles of carbon monoxide is required to reduce 1 mole, right? Here it is 1. So there are no coefficients, so it is considered as 1. So 1 to reduce this 1 mole of ferric oxide, it requires 3. So 3 into what is the standard? It is 22.4. So you have to multiply 3 into 22.4, right? So how much you will get? The answer, it comes to be how much? It comes to be 67.2. Okay. So this is the correct answer, 67.2. So how many moles? You can see clearly from the equation itself. For 1 mole to reduce, it requires 3 moles of carbon monoxide. So you can just simply, you have to multiply. So for 1 mole of ferric oxide, it requires 3 moles. So for, so you have to just multiply it. So 3 into 22.4 gives you 67.2. So this is the correct answer. So we'll go for the next. So next concept is percentage composition. Now what is percentage composition? So percentage composition of an element, it can be calculated in the compound, okay, which can be calculated as mass percent of the element, which is equal to mass of the element in the 1 molecule of compound upon molecular mass of the compound. Okay, so mass percent of the element. So how you have to calculate the percentage composition? It is mass of the element divided by molecular mass of the compound. So based on this, we'll see some of the problems. So what is the percentage of nitrogen in urea? What is the urea formula? Urea, it is NH2, okay, NH2 CO NH2, right? NH2 CO NH2. So this is the formula of molecular formula of urea. So just find out the percentage of nitrogen. So first what you have to find out, you have to first find out the molecular mass of urea. So molecular mass of urea is, okay, so so each nitrogen is what? Each nitrogen is 14. Okay, 14 into how many nitrogens are there? 2. Plus each hydrogen is 1. So how many hydrogens are there? 4. Plus carbon, 1 carbon, carbon is 12 into 1. Plus how many oxygens are there? 1. So 16 into 1. So after solving this, it comes to be, molecular mass comes to be 60. Now, what is the formula? It is mass percent is given as mass of the element. Now mass of the element, which element you have to find of? Nitrogen. How many nitrogens are there in urea? It is 2. So how many it is? 14 into 2 is 28, right? So 28 divided by what is the molecular mass of the compound? It is 60 into 100. Okay, so after solving this, what answer you will get? Just see. What is the answer? Simplify further. Yes, it comes to be 46. Okay, it comes to be 46.66. Correct. So this is the correct answer. So we'll go further. So what is the mass percent of carbon in carbon dioxide? What is carbon dioxide? Carbon dioxide is CO2. Okay. So the molecular mass of carbon dioxide is what? Calculate. Right? So 12 into 1 plus 16 into 2. Right? So what is the molecular mass? It comes to be 44. Okay. So what you have to find? You have to find the percentage of carbon. The element is, so mass percent of the element is equals to mass of the element divided by molecular mass of the compound. So mass percent is equals to, what is the mass of the element? It is how much? It is 12, right? It is 12 and divided by the mass of the compound. It is 44 into 100. So how much it comes? The answer comes to be 27.27%. So correct. B is the correct answer. So we'll go for the next concept. So next concept is empirical formula and molecular formula. Okay. So what is empirical formula? So empirical formula is nothing but it is a formula of compound, okay, which will give you a simplest whole number ratio. It will give you a simplest whole number ratio of various elements, okay, of a particular molecule of a compound. So this is empirical formula. Now, how to find out the empirical formula? Suppose there is what, we'll take an example of hydrogen peroxide. Hydrogen peroxide is what? H2O2. So you want to find out the empirical formula of hydrogen peroxide. So in order to express this empirical formula, what you have to do? First, you have to take what is common in between this. It is having which is a common factor. It is 2. So take the common factor 2 as okay. You take it common and take it out. So what is the simplest whole number ratio? It comes to be, so when you take 2, it comes to be 1:1, right? One hydrogen and one oxygen is left. So it is 1:1. So whenever you are finding the empirical formula, it tells you about the simplest whole number ratio. So it is 1:1. So what is the empirical formula? Then when you take 2 common, it becomes HO. Okay. So this is the method how you are going to find the empirical formula. Further, one more example. Take example of C6H12O6. Okay, that is glucose. So C6H12O6. So whenever you are finding out the empirical formula, first you have to take what is common in between this. 6 is common. So when you take 6 common, this becomes 1. 6 2s are 12. So this becomes H2 and this becomes O. Okay, oxygen. So what is the simplest this whole number of this particular atoms? It is 1:2:1. Okay. So the common factor here is what? It is 6. And the ratio comes to be 1:2:1. And thus, what is the empirical formula? It is CH2O. Okay, so this is the empirical formula. Empirical formula is nothing but you're finding out the simplest whole number ratio by taking out one of the common factor. So like this, you're going to take out the common factor. So how to determine this? What are the steps? First, you have to determine the percentage. Okay, you have to first determine its percentage. What is the second step? Second step is you have to determine its mole ratio. Okay, then what is the third step? Third step, you have to make it whole number ratio. And what is the fourth step? Fourth step is removal of fractions from mole ratio. So we'll see one of the examples, then you'll come to know. Okay. So further, so this was about empirical formula. So you know what is empirical formula? What is empirical formula? It is nothing but it gives you a simplest whole number ratio. So what you have to do, whenever a particular formula is given, you have to take out its common factor. Okay, you have to take out the common factor. Common factor, it starts from 1, 2, it can be 1, 2, 3, 4, 5, 6, etc. Okay. So common factor, any of the common factor you have to take out. Further, it gives you a simple whole ratio. Okay. So whatever the simple whole ratio is there, so further it gives you a molecular formula. Okay. Molecular empirical formula. So what is the next step after finding the empirical formula is molecular formula. So what is molecular formula? What is the difference between empirical and molecular formula? Empirical formula, it tells you about the simplest ratio. Okay, it tells you about the simplest ratio, simplest whole number ratio. What is molecular formula? It tells you about the actual ratio. Okay, it tells you about the actual ratio of the atoms of various elements present in one molecule of compound. So we'll see an example, then you will come to know. So what is the example? Same example we'll take. So what hydrogen peroxide and H6, H12O6, that is glucose. Okay. So H2O2, okay, that is hydrogen peroxide. So molecular formula is nothing but what is the formula given? Molecular formula, you have to find out molecular formula by multiplying your common factor into the empirical formula. Okay, how you will get the molecular formula? This is empirical molecular formula. This is molecular formula is equals to common factor into the empirical formula. Now, what is the common factor? Common factor can be from 1, 2, 3, 4, 5, 6, etc. Okay. So now we had found out. Now, what was the empirical formula? Molecular formula we can calculate. So what was the empirical formula in case of H2O2? It was H and O. What was the common factor? It was 2. Right? So when you multiply 2, it gives you H2O2. So like this, you can find out the molecular formula. Then again, in case of C6H12O6, right? So how to find out? It was molecular formula is equals to N into into empirical formula. So N is what? N is what was the common factor in case of glucose was taken as 6. 6 into what was its empirical formula? CH2O. So it gives you C6H12O6. So like this, you are going to find out the molecular formula. So in case when N is equals to 1, okay, if in the case when N is equals to 1, molecular formula of the compound is equals to empirical formula. Whenever N is equals to 1, molecular formula for compound will be equals to empirical formula. Okay, we'll see based on this. We'll see your question. Okay, empirical formula of a compound is CH2O and its molecular mass is 90. Okay, your empirical formula of a compound is given as CH2O and its molecular mass is 90. The molecular formula of the compound is, okay. So first, what you are going to see? First, we are going to find out the empirical mass. Okay, molecular mass is given. Then we have to find out the empirical mass. So first solution, what we'll do? First is we'll find the empirical formula mass of, what is the empirical formula mass of CH2O. Okay, how much it is? Calculate. Carbon is 12 into 2, plus okay, plus 2 into 1 plus 16. So this comes to be what? It comes to be 30. Okay. And then we have got the molecular mass. How much they have given molecular mass? It is 90. So how to calculate? So N is equals to molecular mass divided by empirical formula mass. Okay. So 90 divided by 30, it gives you the common factor. Okay. Common factor, we got it as 3. So further, how to find out molecular formula? It is by multiplying empirical formula into N, right? So what is empirical formula? CH2O. So multiply this by how much? 3. So what it will give you? It will give you C3H6O3. So which is the correct answer? A. So A is the correct answer. So like this, you're going to solve the problem. Okay, empirical formula of a compound is CH2O. So you have to find out first the empirical mass, followed by find out the common factor, and then multiply the common factor with the empirical formula to get you the molecular mass. So so next is the empirical formula of a compound is CH2O. Okay, the empirical formula is of a compound is CH2O. 0.0835 moles of the compound contains 1.0 gram of hydrogen. Molecular formula of the compound is. So how to solve this particular? So how to find out this? Okay. So what they have given the empirical formula of a compound. So what they have said that 0.0835 moles of the compound contains 1.1 gram of hydrogen. Okay. So since what they have given, what is given, that will write, since 0.0835 mole of compound contains how much gram? 1 gram of hydrogen. Okay, this is given according to the question. This is given. So what we have to find? We have to find out for 1 mole, right? So therefore 1 mole of compound, how much it contains? Okay, how much it contains is equals to how much? So what it will be? Just multiply. Okay, 1 divided by 0.0835. So it comes to be how much? Just see how much it comes to be. Divide 1 by 0.0835. So the answer comes to be 11.97. Okay, 11.97 is nearer to 12. So 12 grams of hydrogen is present. So what you have to do? So 12 grams of hydrogen is present. Now see in the options in which particular this 12 grams is present in A option. So A is the correct. So the empirical formula of a compound is CH2O. So they have given what? They have given the empirical formula and they have given 1 gram of hydrogen is present in so much of mole of compound. So for 1 mole you have to find out. So whenever you're finding for 1 mole of this, you have to just cross multiply. It gives you this answer. So it is nearly to 12. So hydrogen contained is 12 grams. So this is the answer. Okay. So like this, you're going to solve the empirical formula problems. So next is psychometry. Okay. So psychometry and psychometric. Okay. So calculations. So what is psychometry? It is nothing but it is derived from two Greek words. Okay. Psycho means meaning element and metron meaning measure. So you have to measure the masses of reactants and products involved in the chemical reaction. So you are just calculating the masses of reactants and product. So we'll consider an example of methane. So what is methane? What is combustion? Here the example is taken of combustion of methane. What do you mean by combustion? Combustion is nothing but, what is combustion? Combustion is nothing but you are reacting the methane in the presence of oxygen. Okay, you're providing oxygen to it and it is heating up and it will give you some energy. Heat is released. Okay, so combustion. So it is reacting with oxygen. So whenever combustion, so here we are considering the example of combustion of methane. So CH4, methane, which is in gaseous state, reacts with oxygen. Okay, in gaseous state gives you carbon dioxide plus water molecules. Now you can see here this methane and oxygen. It is dioxygen because there are 2 moles, right? 2 atoms of oxygen. It is said to be dioxygen. They are this side. The arrow you can see. Okay, this arrow left hand side is said to be reactants. Okay, these are the reactants. So these will react to give you further products. So here methane and dioxygen are called as reactants and carbon dioxide and water molecule is said to be a products. Okay, so this G, okay, this G, small subscript, whatever is there. So this, it indicates the state. Okay, it indicates the state. So here it indicates what all are written as G. So here all the reactants and products are in gaseous state. Okay, if it is S, small s, so it is in solid state. If it is L, it is in liquid state. So this represents the state of the reactants and products. So here all this particular reactants and products are in gaseous state. Okay, so here what you can see, 1 mole, okay, 1 mole of methane. Here 1 mole of methane reacts with how many moles of oxygen? You can see 1 mole of, how you will call out this reaction, that is 1 mole of methane reacts with 2 moles of 2 moles of dioxygen to give you 1 mole of carbon dioxide and 2 moles of water. Okay, so when you are calling out the reaction, or how you have to say the reaction, it is according to the chemical reaction, it is said to be 1 mole of methane reacts with 2 moles of dioxygens to give you carbon dioxide, 1 mole of carbon dioxide and 2 moles of oxygen. So here this, whatever the 2, 1 it is given, no, it is nothing but coefficients. Okay, so these are the stoichiometric coefficients. So the coefficients here, which is for 2 and this oxygen and water molecules, are nothing but they are called as stoichiometric coefficients. It tells you about how many moles are present. So okay, so here it will tell you. So here you can see the coefficient 2 for oxygen and water are called to be stoichiometric coefficient. Hence, according to our chemical reaction, it is said to be 1 mole of methane reacts with 2 moles of oxygen to give you 1 mole of carbon dioxide and 2 moles of water. Okay. So how like we are calculating the volume of mass. So, volume of gas is given as 22.4 when it is terms of liters. So here when 1 mole is given, whenever you are calculating, now this is 1 mole. So 1 mole is equals to how much? 22.4 liters. Okay. What is the mass? It is 16 grams. You know what is the mass of the molecular mass of methane? It is 16 grams. So when you calculate for oxygen, it is 2 moles. So you have to multiply this by 2. 2 into oxygen, each oxygen is 16, so it is 32. So 32 into 2. Then carbon dioxide only 1 mole, so it is 22.4 liters. So this accordingly, the volume of gas also changes. So carbon dioxide, what is the molecular mass? It is 2. This is not 2, you have to write it 1. Okay, here this is a typing mistake, so it is only 24. Okay, so it is 1 mole, so it is 22.4 liters of carbon dioxide, plus how many moles of water molecules? 2 moles. So 2 into 18, it gives you 44.8. So this many liters of like this, you have to call out the chemical reaction. Okay, so this is, we'll see some of the examples. So what is the question? 1 mole of magnesium nitride. Okay, 1 mole of magnesium nitride on reaction with an excess of water gives. So we'll write out the first, we'll write the reaction. Magnesium. What is magnesium? What is the symbol of magnesium? Anyone? What is magnesium? How do you represent magnesium? And what is its charge? Yes, Mg, correct. Mg, what is the charge? Mg plus 2. Okay, it is Mg plus 2. So Mg plus 2 and nitride. What is the nitride? How do you represent nitride? It is N. Okay, and what is the charge? It is -3. Now, whenever such unequal ions are present, okay, whenever such ions which are having unequal charges, how do you write is its molecular formula? You have to write here Mg is present in +2 and N is -3. Okay. Now, for example, Na. One more, I'll give you the simplest. Na is what? Sodium. It will be always in plus state. Okay, +1 state. Chloride is -1. So what is the molecular formula? 1 and 1, right? When you write, so how do you write? Na, write its charge down, Cl1. So it becomes NaCl, right? Similarly, Ca plus 2, right? Cl is -1. So how do you write these charges? Calcium is 2, this is 1. So you just cross multiply, how much it will be? CaCl2. Like this, same with respect to magnesium nitride. Mg is what? +2. Don't write charge, only 2. Nitride is what? 3. So just cross multiply. What will be the formula? Mg3 and 2. So this becomes magnesium nitride. Understood? So whenever you have ions with different charges, you have to crisscross. Okay, you have to crisscross. And whenever you have the same charges, you have to, it will get cancelled. Okay, and it will come to be like this. So we'll see, we'll write the further equation. So what it comes to be? Mg3 and 2. What is the given? 1 mole of Mg magnesium nitride. So it is 1 mole. Okay. No need to write 1. It is understood. Magnesium nitride react with excess of water. Excess of water will take it as 6 moles of water molecules. Okay. 6 moles of water molecule. What it will give? Just write the, tell me the, this. What will be the products form? Yes, what will be the product form? Please answer fast. So the product formed is 2 MgOH twice. Hydroxide. Okay, hydroxide is formed plus 2 NH3. 2 NH3. So what is the question? 1 mole of magnesium nitride on reaction with excess of water gives you what? So what is the options? 2 moles of ammonia. So this is the correct answer. Okay, after writing the reaction. So 2 mg, your mg. Okay, 3 mg. So it is 3. You see it is balanced or no? Mg 3. Then hydroxide O. Oxygen is how much? 2 3s are 6. So 6 oxygens are there. Hydrogens are how many? 6. 6 hydrogens. Here 6. Right. 3 2s are right. So here also oxygens are there. Hydrogens are there. 12. Here oxygen is 6. Here oxygens are 6. So the answer is 2 moles of ammonia. So you have to write the equation and simplify further. We'll see the next one. So in the synthesis of ammonia, that is N2 Haber's process, right? Ammonia N2 plus 3H2 gives you 2NH3 when 100 ml of N2. So this is 100 ml have reacted with the volume of H2 which has also reacted and ammonia produced. So when the 100 ml of this 100 ml of N2 is reacted, the volume of H2 which has also reacted and ammonia produced. So how many? Here is 3, right? So this is 1 mole. Okay, so this is the volume of N2. I'll just write here 1 volume, right? So this is how many? 3. 3 volumes or 3 moles are there, and here it is 2, right? So 3 into 100, right? How much it is produced? 3 into 100, and this is 2 into 100. So how much it will be? 300 volume of ml of this is reacted, and ammonia produced is 200 ml. So just see which is the correct one. So 300 ml of H2 and 200 ml of NH3. So this is the correct answer. So based upon psychometric coefficients, so you have to find out the answer. So this is the way you are going to solve it. Okay. Okay, students. So these were some of the problems which we have solved today. So thank you. So we'll meet tomorrow for the next class. Okay, thank you.